Alfred Wegener was a meteorologist and Arctic explorer who studied weather patterns and ice formations, not geological structures. When he proposed continental drift in 1912, he was stepping far outside his area of expertise to challenge one of geology's most fundamental assumptions. His theory claimed that all continents had once been joined together in a massive supercontinent he called Pangaea, which had gradually broken apart and drifted to their current positions. The evidence Wegener presented was actually quite compelling. The coastlines of South America and Africa fit together with remarkable precision. Like pieces of a jigsaw puzzle, identical fossil species appeared on continents separated by thousands of miles of ocean, creatures that could never have swum or flown such distances. Mountain ranges and rock formations showed perfect continuity across ocean basins. Glacial deposits appeared in tropical regions, while tropical fossils turned up in Arctic zones. Yet the geological establishment's response was immediate and merciless. Leading geologists dismissed Wegener as an amateur meddling in subjects beyond his comprehension. They ridiculed his evidence as meaningless coincidences and attacked his character as much as his science. The criticism wasn't just professional, it was personal and vicious. The fatal weakness in Wegener's theory was his inability to explain the mechanism driving continental movement. He speculated about rotational forces and gravitational effects, but his calculations couldn't account for the enormous energy required to push continents through solid ocean crust. Without a credible driving force, his theory remained an interesting collection of puzzling correlations with no scientific foundation. For decades, continental drift served as a textbook example of how not to do science. Wegener died in 1930 during a research expedition in Greenland, his reputation in ruins, and his theory thoroughly discredited. Geology students learned about his work as a cautionary tale about the dangers of speculation without proper evidence. Then, something unexpected happened. Military submarines during the Cold War began mapping the ocean floor with unprecedented precision, seeking hiding places and strategic advantages. What they discovered changed everything. The seafloor contained massive underwater mountain ranges called mid-ocean ridges, stretching for thousands of miles across every ocean basin. More importantly, these ridges were actively creating new oceanic crust through volcanic activity. Scientists found magnetic striping in the rocks, perfect records of Earth's magnetic field reversals preserved as new seafloor spread outward from the ridges. They discovered that oceanic crust was much younger than continental crust, and that it became progressively older with distance from the ridges. The evidence pointed to a startling conclusion. The seafloor itself was in motion, carrying continents along as passengers on massive tectonic plates. By the 1960s, Wegener's impossible theory had been reborn as plate tectonics, the unifying principle that explained earthquakes, volcanoes, mountain building, and the distribution of life on Earth. Every geology textbook was rewritten. The amateur meteorologist who had been ridiculed for 50 years was suddenly recognized as a visionary who had seen the truth when everyone else was blinded by conventional thinking. Our next impossible theory challenged something even more fundamental than the stability of continents. It questioned humanity's place at the center of creation itself. For over 15 centuries, Western civilization knew exactly where it stood in the cosmic order. Earth occupied the center of the universe, with the sun, moon, planets, and stars revolving around us in perfect crystalline spheres. This geocentric model wasn't just astronomy. It was theology and philosophy combined into an unshakable foundation of human importance and divine design. Nicholas Copernicus was a Polish church official who spent decades studying astronomical observations and mathematical models. Working in secret, he developed a revolutionary alternative that placed the sun at the center of the solar system, with Earth as just another planet orbiting around it. This heliocentric model explained planetary motions with elegant mathematical simplicity, but it came with terrifying implications. If Earth wasn't the center of everything, then humanity's special status in creation was an illusion. if our planet was just one of several worlds orbiting the Sun, then the entire philosophical foundation of human significance crumbled. Copernicus understood the danger of his ideas perfectly. He kept his manuscript hidden for years, only allowing its publication as he lay dying in 1543. The initial reaction was manageable because Copernicus was safely dead, and his book was written in technical Latin that few people could understand. The real trouble began when Galileo Galilei turned a telescope toward the heavens and started making observations that supported the Copernican system. Galileo saw mountains and craters on the moon, proving it wasn't a perfect celestial sphere. He observed spots on the sun, showing that even the center of the solar system had blemishes. He discovered 4 moons orbiting Jupiter, demonstrating that not everything in the universe revolved around Earth. Most damning of all, he observed the phases of Venus, which were impossible to explain in the geocentric model, but perfectly predictable if Venus orbited the Sun. Unlike Copernicus, Galileo was very much alive and refused to keep quiet about his discoveries. He published his findings in Italian rather than scholarly Latin, making them accessible to ordinary people. He argued for the heliocentric system with wit, sarcasm, and devastating logical precision that made his opponents look foolish. The Catholic Church's response was swift and brutal. The Holy Inquisition hauled Galileo before a tribunal in 1633, threatened him with torture, and forced him to publicly recant his own discoveries. On his knees before his accusers, the aging scientist formally renounced the evidence of his own eyes and declared the Earth to be motionless at the center of creation. Legend claims that as Galileo rose from this humiliating performance, he muttered under his breath the phrase that would become his epitaph. And yet it moves. Whether he actually spoke these words or not, they captured the essential truth that no amount of institutional pressure could change physical reality. Galileo spent his remaining years under house arrest, forbidden from teaching or publishing his work. The persecution was so thorough that it took the Catholic Church until 1992 to formally admit that he'd been correct all along 359 years, to acknowledge that the impossible theory had been true from the beginning. Our third impossible theory emerged from the most unlikely source imaginable, a chemist studying problems in the French wine industry. What he discovered would revolutionize medicine and save more lives than any other scientific breakthrough in human history. In the mid-19th century, hospitals were places where people went to die. Doctors took pride in the blood and gore that stained their surgical coats, viewing it as evidence of their extensive experience. They moved directly from dissecting corpses to delivering babies without washing their hands, believing that gentlemen's hands were inherently clean. The prevailing theory of disease was miasma, the idea that illness spread through poisonous vapors rising from swamps and filth. When people got sick, doctors looked for bad air and foul odors. The notion that invisible creatures too small to see could be responsible for disease belonged in the realm of superstition, not science. Louis Pasteur was investigating why some batches of wine spoiled while others remained perfect. Through his microscope, he observed tiny living organisms that cause fermentation and decay. These microorganisms were everywhere, floating in the air, thriving in organic matter, multiplying with incredible speed. Pasteur made a logical leap that horrified the medical establishment. If these invisible creatures could spoil wine, perhaps they could also cause disease in humans. The reaction from doctors was immediate and furious. They were learned men of science, not primitive witch doctors who believed in invisible monsters. The suggestion that they might be carrying death on their unwashed hands was not just scientifically absurd, it was a profound insult to their professional dignity. The leading biological theory was spontaneous generation, the belief that life could arise from non-living matter. Maggots appeared on rotting meat because life spontaneously emerged from decay. Bacteria grew in sealed containers because living organisms could materialize from nothing. This explained the appearance of microorganisms without requiring them to come from somewhere else. Pasteur designed a series of brilliant experiments to test spontaneous generation. Using swan-necked flasks that allowed air to enter but trapped airborne particles, he showed that sterilized broth would remain sterile indefinitely unless contaminated by dust and microorganisms. From outside, life didn't spontaneously appear. It was introduced by invisible creatures floating in the environment. Despite this clear evidence, the medical establishment continued to resist germ theory with desperate intensity. The implications were too threatening to accept. If microorganisms caused disease, then everything doctors thought they knew about illness was wrong. Their treatments were useless at best and harmful at worst. Their entire profession would need to be rebuilt from the ground up. Pasteur's work inspired other researchers who began applying germ theory to medical practice. Joseph Lister in Scotland started using carbolic acid to sterilize surgical instruments and wounds, achieving miraculous reductions in post-operative deaths. Robert Koch in Germany identified specific bacteria responsible for anthrax and tuberculosis, proving that individual diseases had particular microbial causes. The evidence became overwhelming, but acceptance was slow and painful. Each victory for germ theory meant another defeat for established medical authority. Each successful application of antiseptic techniques was an admission that doctors had been unknowingly killing their patients for centuries. Eventually, the impossible theory that invisible germs cause disease became the foundation of modern medicine. Pasteurization made food safer, vaccination prevented deadly diseases, and antiseptic surgery saved countless lives. The ridiculous idea that had been dismissed as primitive superstition transformed into the most important medical discovery in human history. Our fourth impossible theory challenged one of the most basic assumptions about the nature of the cosmos itself. For most of human history, people looked up at the night sky and saw eternal permanence. The stars occupied fixed positions. The universe stretched infinitely in all directions, and everything had always been exactly as it appeared. The idea that the entire cosmos might be changing, expanding, or evolving seemed to violate the most fundamental principles of physics and philosophy. In the early 20th century, even Albert Einstein believed in a static universe. His equations of general relativity actually predicted that space itself should be either expanding or contracting. But this seemed so impossible that Einstein added a cosmological constant to his calculations, a mathematical fudge factor designed to keep the universe perfectly still. The notion that reality itself might be in motion was simply too radical to accept. Georges Lemaitre was perhaps the most unlikely revolutionary in the history of cosmology. He was both a brilliant physicist and a Catholic priest, combining advanced mathematics with deep religious faith in ways that made his secular colleagues deeply uncomfortable. Working from Einstein's own equations in the 1920s, Lemaitre proposed something that even the great physicist found repulsive. Lemaitre suggested that the universe was not static but expanding, growing larger with each passing moment. More shocking still, he claimed that if you ran this expansion backward through time, everything would converge to a single point of infinite density and temperature. He called this the primeval atom, a moment of cosmic creation when all matter and energy emerge from nothing in an explosive birth of space and time itself. Einstein's response was swift and dismissive. When Lemaitre presented his theory at a conference, Einstein told him directly that while his calculations were mathematically correct, his physics was abominable. The idea of a cosmic beginning sounded too much like religious creation mythology dressed up in scientific language. It violated the principle that the universe should be explicable through natural processes without invoking supernatural intervention. The scientific establishment rallied against Lemaitre's expanding universe with remarkable unanimity. The theory seemed to require a moment of creation, which implied a creator. It suggested that the cosmos had a history, which contradicted the comforting notion of eternal stability. Most troubling of all, it meant that the universe might also have an ending, a heat death, when expansion finally overcame all the forces holding matter together. The ultimate expression of ridicule came from Fred Hoyle, a brilliant English astronomer who championed an alternative theory called steady-state cosmology. Hoyle believed that the universe was indeed eternal and unchanging, with new matter continuously appearing to fill the gaps left by expansion. During a BBC radio broadcast in 1949, Hoyle mockingly referred to Lemaitre's creation event as a Big Bang, intending the phrase as a dismissive joke that would make the theory sound childish and unscientific. The name stuck, but so did the evidence. In 1929, Edwin Hubble made observations that confirmed Lemaitre's predictions. Using the world's largest telescope, Hubble discovered that distant galaxies were all moving away from us, and the more distant they were, the faster they were receding. The universe was indeed expanding exactly as the Belgian priest had calculated. For decades, the steady-state theory fought a rearguard action against mounting evidence for cosmic expansion. Hoyle and his supporters argued that the apparent motion of galaxies could be explained by other mechanisms. They developed increasingly complex models to avoid accepting that the universe had a definitive beginning. The battle between steady-state and Big Bang cosmology became one of the most contentious debates in 20th century science. The final proof came by accident. In 1965, two American radio astronomers named Arno Penzias and Robert Wilson were trying to eliminate a persistent background noise from their sensitive antenna. No matter what they did, they couldn't get rid of the faint hiss that seemed to come from every direction in space. They cleaned bird droppings out of the equipment, checked for electrical interference, and tested every component multiple times. What they had discovered was the afterglow of creation itself. The cosmic microwave background radiation was the faint heat signature left over from the Big Bang, stretched and cooled by billions of years of cosmic expansion, but still detectable by sensitive instruments. It was exactly what Lemaitre's theory predicted should exist, a fossil remnant of the primeval atom that had given birth to space and time. Fred Hoyle's mocking nickname became the official name for the standard model of cosmology. The impossible theory that the universe had been born in a moment of explosive creation was now accepted as scientific fact. The Catholic priest who had dared to give the cosmos a birthday was vindicated, though he lived to see his vindication with characteristic humility. Our fifth impossible theory emerged from the ancient world, but its implications wouldn't be fully understood until modern astronomy revealed just how precisely ancient minds had understood the cosmos. When archaeologists pulled a corroded bronze mechanism from a Mediterranean shipwreck in 1901, they assumed it was some kind of navigational instrument or decorative artwork. No one suspected they were looking at technology that shouldn't have existed for another 1,000 years. The Antikythera mechanism, as it came to be known, was built around 100 BCE by unknown Greek craftsmen. Initial examinations revealed it to be far more complex than anyone had imagined. The device contained dozens of precision-cut bronze gears arranged in sophisticated gear trains that could track the movements of celestial bodies with mathematical accuracy that rivaled modern computers. As researchers began to understand the mechanism's true capabilities, they faced an impossible puzzle. This ancient device could predict solar and lunar eclipses decades in advance, track the complex cycles of planetary motion, and follow the intricate timing of Greek religious festivals and Olympic Games. It incorporated differential gearing, a technology that historians believed hadn't been invented until the 16th century. The mathematical knowledge embedded in the mechanism was equally anachronistic. The gear ratios used precise approximations of irrational numbers that demonstrated understanding of advanced mathematical concepts. The astronomical calculations required knowledge of planetary orbital mechanics that wouldn't be officially discovered until the work of Johannes Kepler in the 17th century. Most puzzling was the question of who could have built such a device. The precision of the metalwork, the sophistication of the mechanical design, and the depth of astronomical knowledge all pointed to a single brilliant engineer who possessed capabilities that seemed impossible for the ancient world. This wasn't the product of gradual technological development over generations, but the work of someone who understood principles of science and engineering that were supposedly lost to history. Modern analysis using advanced imaging techniques has revealed even more impossible features. The mechanism originally contained functions for tracking all known planets, predicting their positions years in advance, and calculating complex astronomical phenomena like the varying speed of the Moon's orbit. The level of precision required for these calculations wouldn't be matched again until the development of mechanical clockwork in medieval Europe. Perhaps most disturbing is what happened to this knowledge. The Antikythera mechanism represents a pinnacle of ancient technology that vanished completely from the historical record. No other Greek devices show similar complexity, and the mathematical principles required to build it seem to have disappeared without a trace. It's as if someone with modern understanding of astronomy and engineering had briefly appeared in the ancient world, created this impossible device, and then vanished, taking their knowledge with them. The mechanism sits in the National Archaeological Museum in Athens, a bronze testament to the possibility that human knowledge doesn't always progress in a straight line. Sometimes breakthrough understanding appears centuries before its time, only to be lost again until humanity is ready to rediscover what was once known. The impossible theory that ancient civilizations possessed advanced scientific knowledge continues to challenge our assumptions about the linear progress of human understanding. Our sixth impossible theory came from the most unlikely revolutionary in scientific history. Leonardo da Vinci is remembered as the ultimate Renaissance genius, a man whose artistic masterpieces and inventive spirit embodied the era's rebirth of learning and creativity. But a closer examination of his private notebooks reveals knowledge so advanced and precise that it raises troubling questions about the source of his extraordinary insights. Leonardo's notebooks contain detailed engineering drawings for helicopters, submarines, tanks, and flying machines that wouldn't become reality for centuries. These weren't vague conceptual sketches, but precise technical blueprints with specifications that demonstrate deep understanding of aerodynamics, hydraulics, and mechanical engineering principles that supposedly hadn't been discovered yet. His helicopter design incorporated complex understanding of lift generation and torque compensation that wouldn't be formally explained until the 19th century. His submarine plans included ballast systems and air supply mechanisms that showed sophisticated grasp of underwater engineering challenges. His tank design featured sloped armor for deflecting projectiles and transmission systems that anticipated automotive engineering by 400 years. Leonardo's anatomical studies displayed impossible accuracy for someone working without modern medical knowledge. His drawings of the human heart included precise details of valve function and blood circulation that wouldn't be discovered until William Harvey's work in the 17th century. His brain dissections showed understanding of neurological structures that wouldn't be identified until the development of modern neuroscience. Most mysterious were his astronomical observations. Leonardo's notebooks contained references to the moons of Jupiter, the phases of Venus, and detailed studies of lunar surface features that were beyond the capability of Renaissance optics. His sketches showed accurate depictions of phenomena that wouldn't be observable until Galileo's telescopic discoveries nearly a century later. Recent analysis has revealed an even more puzzling pattern. Leonardo's most advanced concepts appeared suddenly in his work with no developmental sketches or experimental progression. The handwriting in these sections showed subtle differences from his normal script, as if he were copying from another source, rather than developing original ideas through experimentation and refinement. The mathematical calculations accompanying his designs used techniques that wouldn't be formally developed until the work of Newton and Leibniz centuries later. His understanding of physics principles like momentum conservation, energy transfer, and structural engineering seemed to draw from knowledge that simply didn't exist in his historical period. Was Leonardo da Vinci simply a genius so far ahead of his time that his insights anticipated future discoveries? Or did he somehow have access to knowledge from beyond his era? His notebooks read less like the experimental work of an inventor and more like technical documentation from someone who had already seen these technologies in operation. The precision of his designs and the accuracy of his scientific observations suggest a man who wasn't predicting the future so much as remembering it. Our seventh impossible theory challenged one of medicine's most sacred assumptions about the nature of disease transmission. In the 1840s, Vienna General Hospital was considered one of Europe's most advanced medical institutions, yet it harbored a deadly mystery that defied all conventional medical wisdom. The hospital operated two separate maternity clinics. The first was staffed by male doctors and medical students, while the second employed female midwives. Women giving birth in the doctor's clinic were dying from childbed fever at rates 5 to 10 times higher than those in the midwives' ward. The disparity was so extreme that pregnant women would beg to be admitted to the midwife clinic, and some chose to give birth in the streets rather than enter the physician's ward. Ignaz Semmelweis was a Hungarian doctor who became obsessed with solving this horrifying puzzle. He investigated every possible difference between the two clinics, examining birthing positions, religious practices, ventilation systems, and dietary factors. Nothing explained why women were dying at such dramatically different rates in facilities that were otherwise identical. The breakthrough came through tragedy. A close friend of Semmelweis, a pathologist, died after accidentally cutting himself with a scalpel during an autopsy. The symptoms of his death were identical to those of women dying from childbed fever. This observation led Semmelweis to a shocking realization that violated everything the medical establishment believed about disease. The doctors and medical students in the first clinic routinely performed autopsies on corpses in the morning, then went directly to examine pregnant women and deliver babies without any cleaning procedures. The midwives never handled dead bodies. Semmelweis theorized that doctors were carrying some kind of deadly substance from corpses to living patients, transmitting death through direct contact. This theory was medically impossible according to established knowledge. Disease was caused by miasma, poisonous vapors that spread through the air. The idea that invisible particles could cling to hands and cause illness belonged to primitive superstition, not modern medicine. Gentlemen physicians were clean by definition, and their hands could not possibly carry infection from patient to patient. Despite having no understanding of bacteria or germ theory, Semmelweis instituted a radical policy in 1847. All doctors and students were required to wash their hands in chlorinated lime solution before entering the maternity ward. The results were immediate and undeniable. Mortality rates in the doctor's clinic dropped by 90%, falling below even the midwives' already low numbers. The medical establishment's response was not gratitude, but fury. Semmelweis had insulted the dignity of educated physicians by suggesting they were carriers of death. His theory implied that respected doctors were responsible for killing their own patients through ignorance and poor hygiene. Without scientific proof beyond statistical evidence, his claims were dismissed as offensive speculation. The persecution was systematic and brutal. Medical journals refused to publish his findings. Hospital administrators rejected his hand-washing protocols. Senior physicians launched personal attacks on his character and competence. Eventually, the medical establishment drove him out of Vienna General Hospital and effectively ended his career. Semmelweis grew increasingly bitter and erratic as he watched women continue to die from preventable infections. He wrote angry letters to prominent obstetricians across Europe, calling them murderers for refusing to adopt his simple prevention methods. His behavior became so confrontational that colleagues began questioning his mental stability. In 1865, Semmelweis was committed to an insane asylum where he died 2 weeks later from blood poisoning, caused by an infected wound on his hand. He died from the very type of infection his hand-washing technique was designed to prevent, a tragic irony that symbolized medicine's deadly resistance to his impossible theory. Only after Louis Pasteur's work on germ theory gained acceptance did the medical world realize the catastrophic error they had made. Ignaz Semmelweis, the man they had destroyed for suggesting that doctors' hands could carry death, was posthumously recognized as a pioneer who had discovered one of medicine's most important principles decades before the science existed to explain it. Our eighth impossible theory emerged from the depths of African folklore and challenged Western science's arrogant assumption that all significant discoveries came from European laboratories and universities. For centuries, explorers and traders had returned from Africa with tales of massive, hairy, man-like creatures of incredible strength and intelligence that lived deep in the continent's impenetrable forests. These stories were systematically dismissed by European and American scientists as primitive mythology. The accounts were lumped together with legends of sea monsters and unicorns, the kind of fantasy tales that uneducated natives told to impress gullible visitors. Serious zoologists knew that such a large primate species could not exist without proper scientific documentation. The scientific consensus was ironclad. Africa had been sufficiently explored that any significant animal species would already be known to Western taxonomists. The absence of specimens, skeletons, or credible eyewitness accounts from educated Europeans proved that these giant apes were figments of imagination, probably exaggerated descriptions of known species like chimpanzees or baboons. Thomas Savage was an American missionary and physician working in Liberia during the 1840s. Unlike his academic colleagues back home, he took local knowledge seriously and listened carefully to indigenous accounts of forest creatures. When tribal leaders showed him skulls and bones of the mysterious giant apes, he recognized immediately that they belonged to an unknown species. Savage collaborated with Jeffries Wyman, a renowned anatomist at Harvard University, to provide the first scientific description of what they named troglodytes gorilla. Their 1847 paper was based entirely on skeletal remains, but it provided compelling evidence that a new species of great ape existed in equatorial Africa. The scientific community's response was cautious skepticism. Bones were interesting, but extraordinary claims required extraordinary proof. The world wanted to see living specimens of these alleged giant apes before accepting that Western science had overlooked such a significant discovery. That proof came from Paul du Chaillu, a French-American explorer who mounted expeditions into the deepest parts of equatorial African forests during the 1850s. He became the first European to observe living gorillas in their natural habitat, documenting their behavior and successfully hunting several specimens for scientific study. When du Chaillu returned to London with gorilla skins, skeletons, and detailed field notes, the reaction was explosive. His exhibitions drew massive crowds, but also intense controversy. Critics accused him of fabrication, suggesting that he had somehow constructed fake specimens or exaggerated encounters with known animals. The physical evidence was undeniable, however. The massive skulls, powerful limb bones, and distinctive anatomical features clearly belonged to a primate species unlike any known to science. The creature that had lived only in African folklore and explorer tales was officially recognized as a real animal that had somehow escaped Western scientific attention for centuries. The gorilla's existence forced European science to confront an uncomfortable truth about the limitations of their knowledge and the value of indigenous expertise. Local African communities had known about these animals for generations, developing sophisticated understanding of their behavior and ecology that Western explorers had dismissed as primitive superstition. Our ninth impossible theory came from the study of bizarre neurological diseases that seemed to violate biology's most fundamental principles. By the late 20th century, the central dogma of life science was absolutely clear. Infectious diseases required living organisms to spread from host to host. Viruses, bacteria, fungi, and parasites all contained genetic material that allowed them to reproduce and transmit illness. This created a disturbing puzzle for medical researchers studying a class of rare but horrifying neurological conditions. Diseases like scrapie in sheep, bovine spongiform encephalopathy in cattle, and Creutzfeldt-Jakob disease in humans were clearly infectious. Scientists could transmit these conditions by injecting brain tissue from affected animals into healthy subjects. Yet despite decades of intensive research, no one could identify the infectious agent responsible. There was no virus, no bacterium, no fungus, and no parasite that could account for these devastating brain diseases. The causative agent remained completely invisible to every detection method available to modern biology. Stanley Prusiner was a neurologist at the University of California who became obsessed with solving this medical mystery. In 1982, he published a paper proposing a solution so radical that it was immediately branded as biological heresy by virtually every expert in the field. Prusiner claimed that the infectious agent was not a living organism at all, but a simple protein that had somehow become misfolded into a dangerous configuration. This rogue protein, which he named a prion, could act as a template that caused other normal proteins to adopt the same lethal shape in a self-perpetuating chain reaction. The concept was biologically impossible according to established science. Proteins were passive molecules that couldn't replicate themselves without genetic instructions from DNA or RNA. The idea that a misfolded protein could somehow reproduce and spread infection violated every principle of molecular biology that scientists had spent decades establishing. The reaction from the scientific community was swift and merciless. Prusiner was labelled a crackpot whose theories belonged in science fiction rather than legitimate research journals. Grant applications were rejected, conference presentations were ridiculed, and his academic career teetered on the edge of complete collapse. The criticism wasn't just professional, but deeply personal. Colleagues questioned not only his scientific competence, but his mental stability. The suggestion that proteins could behave like living infectious agents was so fundamentally wrong that many scientists viewed it as evidence of psychological problems rather than innovative thinking. For over a decade, Prusiner and his small team of supporters conducted meticulous experiments to prove their impossible theory. They purified the infectious agent from diseased brain tissue, demonstrating that it consisted entirely of protein with no nucleic acids present. They identified the gene that produced the normal version of the protein and showed that animals lacking this gene were immune to infection. The breakthrough came during the mad cow disease epidemic that swept through Britain during the 1980s and 90s. When scientists discovered that this animal disease could jump to humans, causing variant Creutzfeldt-Jakob disease, the urgency of understanding prion diseases became undeniable. Evidence accumulated that supported every aspect of Prusiner's heretical theory. The infectious agent was indeed a misfolded protein that could convert normal proteins into dangerous forms. The mechanism of infection involved template-directed refolding rather than conventional reproduction with genetic material. In 1997, Stanley Prusiner was awarded the Nobel Prize in Physiology or Medicine for discovering prions and revolutionizing understanding of infectious disease. The man who had been ridiculed as a delusional amateur was suddenly recognized as a pioneer who had identified an entirely new principle of biological infection. Our 10th and final impossible theory takes us back to the very beginning of scientific observation, to a time when the boundary between mythology and reality was still being established through careful investigation of the natural world. Throughout human history, people had reported seeing rocks fall from the sky, accompanied by brilliant flashes of light and thunderous sounds that shook the earth. These accounts were systematically dismissed by Enlightenment scientists as primitive superstition. The Age of Reason had established that the universe operated according to rational, predictable laws. The heavens were perfect and unchanging, composed of crystalline spheres that rotated in eternal harmony. Objects could not simply materialize in empty space and plummet to Earth. The French Academy of Sciences, Europe's most prestigious scientific institution, declared that rocks falling from the sky were physically impossible. Leading intellectuals explained away eyewitness reports as misidentified lightning strikes, volcanic explosions, or outright fabrication by ignorant peasants seeking attention. When two Yale professors reported observing a meteorite fall in Connecticut, President Thomas Jefferson himself dismissed their account with scientific skepticism. As a man of reason and learning, Jefferson found it easier to believe that respected academics would lie than that stones could fall from heaven without any natural explanation. The scientific consensus was supported by logical reasoning. If rocks regularly fell from the sky, where did they come from? The space between celestial bodies was empty vacuum, incapable of containing solid matter. The idea that debris could somehow exist in this void and randomly plummet to Earth violated every principle of Newtonian physics. Ernst Chladni was a German physicist who decided to approach these folklore accounts with systematic scientific investigation. Instead of dismissing eyewitness reports as superstition, he collected and analysed hundreds of historical accounts from across Europe and beyond, looking for patterns and common elements. Chladni's 1794 publication compiled centuries of meteorite sightings, noting the remarkable consistency in descriptions of fireballs, sonic booms, and the unique composition of recovered stones. He argued that the sheer volume and similarity of reports from independent sources across different cultures and time periods suggested a real phenomenon rather than mass delusion. The scientific establishment ignored Chladni's work completely. His suggestion that stones could have extraterrestrial origin was so ridiculous that it didn't merit serious consideration. The idea belonged in the same category as astrology and alchemy, primitive beliefs that rational science had already disproven. Then, on April 26, 1803, the impossible became undeniable. A brilliant fireball streaked across the sky over Normandy, France, followed by a series of explosive sounds that were heard for miles. More than 3,000 meteorite fragments rained down on the town of L'Aigle, witnessed by hundreds of people who could not all be dismissed as deluded peasants. The French Academy was forced to send Jean-Baptiste Biot, a respected physicist, to investigate this mass of evidence. His meticulous report confirmed every detail that had been dismissed as folklore for centuries. The stones were real. They had indeed fallen from the sky, and their composition was unlike any terrestrial rock. The scientific world was forced to accept that the universe was far stranger and more dynamic than Enlightenment philosophy had assumed. The neat, orderly cosmos of crystalline spheres and empty vacuum was replaced by a more complex reality, where solid matter could indeed travel through space and occasionally intersect with Earth's orbit. The impossible theory that rocks fall from heaven became one of the foundations of modern astronomy and planetary science. What had been dismissed as primitive superstition for centuries was revealed as accurate observation of natural phenomena that science simply hadn't been ready to understand. These 10 impossible theories share a profound lesson about the nature of human knowledge and scientific progress. Each breakthrough was initially rejected, not because the evidence was weak, but because it threatened the comfortable certainties that defined rational thought in its time. The pattern repeats with unsettling consistency across centuries and disciplines. Brilliant observation meets institutional ridicule, truth battles orthodoxy, and reality eventually forces acknowledgement of what was once deemed impossible. What unites these stories isn't just the courage of individual researchers, but the systematic blindness of established expertise. The same intellectual confidence that drives scientific advancement can become its greatest obstacle when new discoveries challenge fundamental assumptions. The experts who dismissed continental drift, heliocentrism, germ theory, and expanding universes weren't stupid or malicious. They were prisoners of paradigms so deeply embedded that alternatives seemed literally unthinkable. Perhaps most unsettling is the realization that this pattern continues today. Right now, there are researchers proposing theories that sound just as impossible to us as these 10 once did to their contemporaries. The next revolutionary breakthrough in physics, biology, or cosmology is probably being ridiculed at academic conferences and rejected by funding committees who cannot imagine that reality might be stranger than current models suggest. The true lesson of these impossible theories isn't that experts are always wrong, but that the boundaries of the possible are far more flexible than we dare to believe. Today's scientific impossibility may well become tomorrow's textbook fact, reminding us that the universe consistently proves more mysterious and wonderful than human minds can easily comprehend.